Here's a few more remarks on probabilistic models. And this is, and that's effectively what we're going to, the vector space is the formulation. Now we're going to try to make more precise how we use the vector space or similar ideas. So we want to get this relevance, and so we want to find the relevance as a function of the query and the document. So we will try to return you the document ranked highest, which is the one which has the highest probability of being relevant. So that's basic principle, and we need to find these probabilities, which is what we're basically discussing. So if you do a probabilistic model, the basic idea is we want to find the probability that the document T is what the user wanted and is useful to the user. And this is slightly wishy-washy, but this is actually what probabilities are, and we will discuss that a little more deeply when we discuss them. Some of the key ideas behind Bayesian ideas, because Bayesian has an interesting debate which has gone on for an awful long time about Bayesian view of probability versus a frequency view of probability. The probability is very powerful. We should try to use probability if we can. Of course, nothing can take away the fact that we need to characterize usefulness. That's where we came up with this fancy formula with TF-IDF formula, and which is going to be used to build the relevance. And so that here we have the document representation. That's the TF-IDF. We have a query. We need to determine the relevance. And if we have the same representation, they're obviously both relevant or both irrelevant, or they actually have the same relevance. So that's clear. So we're going to, this is our basic idea of search. We're going to just find the set. This is, remember, we have this recall and precision. We're going to find all relevant documents, and then we're going to return the most relevant documents, because we learned that users tend to only look at the first page of results anyway. So that's 20 or so possible results. So we need to know whether the concept of a probability can be thought of as, in a fashion that we'd like to think about it, is that it is the likelihood that the answer is what the user wanted. And that is a little different from actually how it's mathematically defined, namely that we actually said the document is irrelevant or irrelevant. So we need to have a little discussion of what probability means, whether it's, and that's connected with this, what Bayes means. So let's discuss that. So this is a difference between, discussion of difference in frequency and Bayes. So if you look at probability, there are two types of ways of thinking about probability. So the simplest one is the expected frequency of something happening in the long run. So if when the weather forecast says that there is a 50% chance of rain, which there is actually a 30% chance of rain at the moment as I speak, that says that if we had 30 days like this, then in 9 of those days we would have rain, because that's 30% of 30. That's the frequency view. But there is another way of thinking about that 30%, which is the Bayesian approach, which is the probability is a degree of belief. Namely, that today, because we only have one today, so what happens in 30 versions of today is irrelevant, because I can't live 30 versions of today. So today, we have a degree of belief of 30% that it will rain. So that's the Bayesian view. So the frequency view requires us to be able to keep on doing experiments. That these experiments are random, and we can keep counting the number of times an event occurs. Then the probability is the limit of this frequency in lots of trials. So they give this example here of weather, except weather is should be spelled W-E-A-T-H-E-R, but it's still weather. Namely, that was what I said. If we take days and take similar days and ask if 30 similar days we get 9 rain, that's the frequency view of probability. But if we roll dice, we're meant to have a chance of 1/6 that a die with the numbers 1 through 6 on them, any given number turns up. So those are frequency views. You toss the die 100 times, every number occurs 100 over 6 times with the usual um, um, error formulae. But for enough events, the fraction will always be 1 over 6. And that will get better and better as we keep on repeating that experiment. So the probability of belief is an alternative way of looking at probability. And this is associated with Bayes, and it's a very important way of viewing probability, and is actually the most powerful. And that probability degree of belief can be individual, it can be rational, it can be irrational, and it can always be changed due to additional knowledge. And you can have things like the probability that there is life on other planets. For a frequency person, that doesn't make much. Well, you could have two views of that. The probability of there being life on other planets, you'd have to have, if here we're saying, if there's any other planet with life on it. The trouble about the frequency view of that probability is you'd have to actually have lots of universes and say, if the probability is 23%, if I have 100 universes, 23 universes will have life on other planets, and the other 77 will not. And there's also, here we have passing this course's exam. What is the probability? Well, you only take the exam once, so it's either 0 or 1 is the actual result. You may not do that experiment in a frequency sense. But still, the concept of probability is useful.